The catalog of mysterious objects drifting through our solar system has grown stranger and more intriguing with the arrival of 3I/Atlas, the third confirmed interstellar visitor to pass through our cosmic neighborhood. From the moment astronomers first spotted the object racing across the sky, it has challenged expectations, invited speculation, and forced scientists to reconsider what they thought they knew about bodies originating beyond our solar system. What began as a routine detection has now evolved into one of the most puzzling astronomical stories in recent years. Researchers monitoring 3I/Atlas have been confronted with a series of baffling observations, beginning with an unexpected shift in the object's color, followed by another change just weeks later, and culminating in a strange pattern of non-gravitational acceleration that cannot be explained by traditional physics alone. The color transformations are particularly perplexing, and reports indicate that even specialists at NASA and other space agencies have been left scratching their heads as they work urgently to understand what could be causing such behavior. The story of 3I/Atlas began on July 1st, when the asteroid terrestrial impact last alert system, better known as ATLAS, detected a fast-moving object whose trajectory and speed immediately raised eyebrows. Its velocity was far too high to be a typical solar system body, and calculations showed that its orbital eccentricity was between 1 and 6.2, an extreme value that placed it firmly in the category of hyperbolic objects not bound to the Sun. In simple terms, it was passing through at incredible speed, never to return, and it did not come from anywhere familiar. This placed it in the very exclusive club of interstellar objects that have visited our system, joining the enigmatic 1I/Oumuamua and the far more comet-like 2I/Borisov. Yet even compared to those unusual predecessors, 3I/Atlas has proven to be a uniquely difficult puzzle for astronomers. From early observations, astronomers identified features consistent with cometary behavior. Spectral measurements suggested outgassing, the release of volatile materials triggered by heat from the Sun, which typically gives comets their shining halo or tail. Despite that, nearly every other feature they observed hinted at something unusual. Instead of behaving like comets native to our solar system, which tend to follow predictable chemical and physical patterns, 3I/Atlas displayed quirks that seemed out of place. Some researchers have floated the idea that it may be a near-pristine remnant from an ancient era of the universe, potentially 10 billion years old, surviving largely unchanged since the early days of cosmic formation. If that is the case, then this visitor represents a rare scientific gift, a time capsule from a completely different stellar environment, shaped by the conditions of a distant, long-evolved star system. Examining such an object could allow scientists to peer into the distant past and learn about the kinds of materials, temperatures, and cosmic forces that shaped worlds far beyond our own. However, despite the excitement, the investigation hit a roadblock when the comet approached its perihelion, the closest point to the Sun in its trajectory. From Earth's perspective, the object passed behind the Sun and became unobservable for a period of time. This blackout is common when objects orbit near the Sun, but the timing of this event immediately fueled speculation among those already interested in 3I/Atlas for reasons beyond standard astronomy. Harvard astronomer Avi Loeb, known for his willingness to consider unconventional hypotheses, pointed out that if an alien spacecraft were attempting to maneuver discreetly within our solar system, it might choose to hide its motion behind the Sun, where human telescopes cannot observe it. Loeb argued that a technologically sophisticated extraterrestrial probe could theoretically use the Sun as a shield to execute a change in direction or velocity without being detected. Although such ideas captured public attention, the vast majority of astronomers dismissed these interpretations. They pointed out that the object's behavior, especially its outgassing, aligned strongly with natural cometary processes. Organizations such as SETI and NASA have made it clear that based on everything currently observed, there is no compelling evidence to support the alien spacecraft hypothesis. They also noted that similar speculation surrounded Oumuamua in 2017 because of its oddly shaped light curve and unexplained acceleration, but later analyses have proposed natural explanations, such as the release of hydrogen or nitrogen, to account for the observed behavior. The scientific community generally prefers explanations rooted in well-understood physics unless extraordinary evidence forces a different conclusion, and no such evidence has emerged here. Yet even with the extraterrestrial probe idea rejected by mainstream astronomers, the reappearance of 3I/Atlas after emerging from behind the Sun became an important moment. It offered a rare chance to test Loeb's speculative hypothesis. If the object suddenly exhibited an abrupt change in trajectory or displayed behavior inconsistent with natural cometary forces, then scientists would have to reevaluate their assumptions. For weeks, there was a heightened sense of anticipation, not because astronomers genuinely believed they were about to witness alien intelligence in action, but because this was an opportunity to observe an interstellar object during a unique phase of its journey, one that could reveal new information about its structure, composition, or origin. When 3I/Atlas became visible again, astronomers quickly resumed their measurements, and that was when the latest surprises emerged. The object had not only changed color again, marking its second major shift, but it also appeared to be accelerating in ways that gravitational forces alone could not account for. Typically, comets exhibit non-gravitational acceleration because jets of gas and dust erupt from their surface as they warm in sunlight. These jets function like miniature rocket thrusters, pushing the comet slightly off its expected path. However, the acceleration observed in 3I/Atlas seems inconsistent with the typical pattern seen in solar system comets, raising new questions about how much we truly understand about interstellar bodies. The color changes pose another challenge. Most comets have relatively stable spectral signatures, although they can vary depending on which minerals vaporize at different temperatures. The shifts in 3I/Atlas, however, are more extreme and do not follow the usual heating and cooling cycles seen in familiar comets. One hypothesis is that the object could contain rare or exotic materials that react differently to solar radiation. Another possibility is that cosmic rays and extreme environmental conditions in interstellar space may have altered its surface over billions of years, creating layers that vaporize in unexpected ways. Since the comet likely originated from a star system with different elemental ratios than our own, its behavior could reflect exotic chemistry that astronomers are only beginning to explore. As the object continues its journey out of the inner solar system, scientists are working to collect as much data as possible before it slips away forever into the vast emptiness between stars. Each new observation contributes to a growing body of knowledge about how interstellar objects form and evolve. Even though the alien spacecraft theory remains firmly in the realm of speculation, 3I/Atlas serves as a reminder that the universe is filled with mysteries that challenge our understanding. Cosmic visitors like this expand our scientific horizons by presenting puzzles that demand fresh thinking, new models, and creative ideas grounded in evidence. The excitement surrounding 3I/Atlas is not merely about the object itself, but about what it represents, a rare and fleeting chance to study material from a completely different region of the galaxy. Such opportunities are incredibly limited, given that interstellar objects passing through our solar system appear to be exceedingly uncommon, or at least extremely difficult to detect. Before 2017, not a single one had been confirmed in all of recorded history. Now, with 3 confirmed in less than a decade, astronomy is entering a new era where interstellar science becomes increasingly important. These objects remind us that the solar system is not isolated, but part of a vast and dynamic galaxy where material is constantly moving, colliding, drifting, and evolving across unimaginable distances and timescales. Ultimately, the strange color shifts, mysterious acceleration, and ancient origins of 3I/Atlas make it one of the most fascinating interstellar visitors yet. Although astronomers may not have all the answers, they continue to gather clues, knowing that each piece of information helps unravel a larger story about our place in the cosmos. And even though the alien hypothesis has once again been set aside, the enduring curiosity it sparked reflects something essential about humanity: our desire to understand the unknown, to question the mysterious, and to push the boundaries of what we believe is possible.